In this lesson, we will discuss the various sources of air available to an aircraft's pneumatic system. We will also look at some basic cabin heating systems. Most aircraft have a pneumatic system of some sort. Large modern airliners have a high-volume, low-pressure system, supplying a bleed air manifold with air from the engine compressors. These systems are covered in a separate lesson. Light aircraft may use ram air, a dynamic air pressure created by the aircraft's motion, to operate gyroscopic instruments. They can also use ram air heated by the engine exhaust gases or by a combustion heater to heat the cockpit and cabin and to demist the windscreen. On some aircraft, where air from the engine compressor is not available, such as on large pressurized piston engine aircraft and some turbopropeller types, blowers driven by the engine are used to supply air to the air conditioning and pressurization systems. Some older turboprop aircraft use high-pressure pneumatic systems to operate the landing gear and brakes. The only example of this still in common use is in the Fokker F-27. The operation of this type of pneumatic system is covered in the hydraulic series of lessons. First, we will look at the ram air systems used in light aircraft. Outside air is introduced to the cabin through forward-facing air intakes. Some of this ram air can be heated by an exhaust gas heater or a combustion heater, and then mixed with the cold ambient air in varying proportions to give a comfortable cabin temperature. A typical system for a light aircraft using an exhaust gas heater is shown here. It also features hot windscreen demisters and a fresh air blower for use on the ground when there is no ram air. The heater muff or exhaust muff is a close-fitting cowl around the exhaust pipe, which allows ram air to come into close contact with the hot exhaust pipe to provide hot air for heating the cabin and demisting the windscreen. Fresh, cold air is allowed into the cabin through the ram air inlets on the wing leading edge. After use, the air is dumped overboard through a vent on the underside of the aircraft. This type of heater requires regular inspections to ensure that toxic exhaust gases do not enter the manned areas. Some aircraft have a blower which can be used on the ground to blow fresh air into the cabin, giving some cooling on hot days. Some aircraft use a combustion heater rather than an exhaust gas heater. The combustion heater is a standalone device. It normally uses the same fuel as the aircraft's engines. It burns about half a gallon an hour. This needs to be taken into account when calculating the fuel required for a particular flight. It works by burning a fuel-air mixture within its combustion chamber. Air for combustion is supplied by a fan or blower, known as the combustion blower, and the fuel is supplied via a solenoid-operated fuel valve. The flame is lit by an ignition unit controlling an igniter. The fuel valve and the igniter are controlled by duct temperature sensors, but can be manually overridden. The system is designed with the fan pushing the air into the cabin being much more powerful than the combustion blower fan. This means that the clean air is at a higher pressure than that in the combustion chamber, so there is no possibility of leaks from inside the chamber contaminating the cabin air. The combustion heater is provided with a number of safety devices, which will include an automatic shut-off if the outlet air temperature becomes too hot, and adequate fire protection in the event of failure of the structural integrity of the combustion chamber. This will normally be a system for shutting off the fuel and sealing the air ducts if flames enter them. An automatically operated fire extinguisher is also incorporated in some systems. A cabin air supply may be provided by blowers driven through the engine accessory gearbox, or by turbo compressors driven by bleed air. Such systems are necessary for piston-engined aircraft and are used for some turbojet aircraft, where the air supply from the compressor is considered to be too dirty or contaminated for use in the air conditioning system. These blowers operate in a similar manner to the superchargers fitted to some piston engines. They may either have a centrifugal or a positive displacement type blower fitted. One type of positive displacement blower is known as the Roots blower. It is named after the Roots brothers, who first patented the basic design in 1860. It consists of two lobes which mesh together and are rotated by the engine gearbox. Air is pulled in through the inlet and expelled through the outlet. The pressure increase across the blower is small. However, this type of blower can produce large flow rates. Shown here is a simple schematic diagram of a cabin conditioning system using a Roots blower. Because of the design of the blower, the air comes out of it in short pulses. This can cause a thumping noise in the air conditioning ducts. The silencer helps to smooth out the airflow, reducing the noise. The blower must be capable of supplying the required mass flow of air under all operating conditions, which means that at high engine speed and low altitude, too much air is supplied. A mass flow controller signals a spill valve to vent the excess airflow to atmosphere. The air can be heated by restricting the flow by means of a variable restrictor, known as a choke valve, which can be progressively closed to increase the pressure and thus the temperature of the air leaving the blower. The hot and cold air supplies are mixed in varying proportions to maintain the delivery temperature at a comfortable level for both passengers and crew. Selection and control may be automatic or manual. The operation of the pack valve, hot air bypass valve, cooling pack and water separator is explained in the air conditioning lesson. In this lesson, you should have learned that most aircraft have a pneumatic system of some sort. On light aircraft, it usually consists simply of ram air, heated by either the exhaust gases or by a combustion heater, being used to warm the cabin. On larger aircraft, where the air is required to supply a pressurization system, it may be supplied by a cabin supercharger, or engine bleed air may be used.